Hello everyone, in this video we're going to look at the written assignment 3. So the first question, graph the function fx equals 4x squared minus 4x plus 3. So given the vertex, vertex is negative b over 2a. Okay, so it's going to be, you plug the point into it, so f negative b over 2a. Okay, this is the vertex. So a equals 4, b equals negative 4. So you plug it in. So the plug into here, the vertex is going to be negative b. So it's negative 4, negative 4 over 2 times 4, and which is 1/2. Okay, this is the x value. So plug 1/2 into the formula. F 1/2 is going to be the y value. Find that by yourself. Okay, so plug 1/2 into the formula, into the function. Plug 1/2 into the function. This is vertex, and x-intercept y equals 0. X-intercept y equals 0. And basically you solve for x squared minus 4x plus 3 equals 0. Solve for x. This is x-intercept. And y-intercept, x equals 0. Plug x equals 0 into the function f0 equals 4 times 0 squared minus 4 times 0 plus 3, which is 3. Okay, then domain is negative infinity to positive infinity. The range is, if you graph the picture, the vertex, you know, this is going to be, if you graph it is 1/2, and you have some point, I don't know what the point is, you need to find this value. The range is, since it's a is positive, a equals 4 is positive, is open upward, so you have a minimum value. So it's going to be start this value to, it's going to be started this f 1/2. You have to find out f 1/2 by yourself, okay, to infinity. And then you figure out this is decreasing from negative infinity to 1/2 is decreasing, from 1/2 to infinity is increasing. That's pretty simple, right? Alright, so problem 2. Use synthetic division to perform the division. Since x plus 2 is factor is x plus 1/2. So if we use the synthetic division, it's going to be 1, 1, 1/2, 1 over 8, which is the coefficient of the polynomial. So if it's x plus 1/2, then we do minus 1/2. Because you change that x plus 1/2 into x minus 1/2, minus negative 1/2. So this is your divisor. Then bring down the 1, multiply it, give you negative 1/2. Add it, okay, use added. Add it, so the 1 plus negative 1/2 is 1/2. Then you multiply it, is negative 1/4. Then you add it, 1/2 plus negative 1/4 is 1/4. And then you multiply it, so it's negative 1/8. You add it, is 0. So your efficient is going to be, figure out this one by yourself. Okay, so this is the this is the remainder, this is a constant, there's the x here, there's x squared here, so the x squared plus half x plus 1/4. Okay, you do that by yourself. I should skip this process actually. Find the polynomial function with the real coefficient, at least the degree have 1 minus square root of 3, 1 plus square root of 3, and 1. So at least find the polynomial with real coefficient, at least the degree have zeros. So if we have zeros, 1 minus, basically if you have one root is 1, so it's x minus 1 is the factor. And x minus 1 minus square root of 3 is one of the factor. X minus 1 plus square root of 3 is the factor. So this is the polynomial function. Okay, have 3 roots, have 3 zeros. So you need to figure out, simplify it. All right. The next one, number 4. Number 4 is pretty much the same thing as number 1. So number 4, fx equals x cubed minus x squared minus 2x. What you need to do, you factor x out, you have x squared minus x minus 2. Then you factor more, you have x minus 2, and x plus 1. So basically you're going to have 3 zeros. X equals 2, x equals negative 1, and x equals 0. So if I have 3 zeros, the 0 is 0, negative 1, and 2. Since this is it's positive x cubed, so it's going to be in this way, right? So now, since it go across and since all of them are one piece, there's no square here. So it's just across the point, cross the point, cross the point, cross the point, okay? And then find x-intercept, find y-intercept, y-intercept. Okay, y-intercept is x equals 0, give you y-intercept. And the y-intercept is pretty obvious. Plug x equals 0 into f0 equals 0 cubed minus 0 squared minus 2 times 0, which is 0. So this is the y-intercept, 0, 0. Okay. And the end behavior, x goes to infinity, y goes to infinity, x goes to negative infinity, y goes to negative infinity. Number 5, for the rational function, fx equals x minus 2, x minus 5, x squared plus 9. Determine the domain of the function. So the x squared plus 9 not equal 0 for all x goes to r. Because this is positive, it's always positive. Plus number is always positive, so it will never be 0. So domain is negative infinity to positive infinity. Find any vertical asymptote. Vertical asymptote is when vertical asymptote y goes to infinity. Okay, there's no vertical asymptote. Because x0 plus x squared plus 9 is not 0, so there's no vertical asymptote. Find a horizontal asymptote. Horizontal asymptote when x goes to infinity. X goes to positive or negative infinity. X goes to positive negative infinity. What is y? Okay, so you find a limit x goes to infinity f of x, which is x squared minus 7x plus 10, x squared plus 9. If x goes to infinity, so you can divide the top and the bottom by x squared is 1 over 7 over x plus 10 over x squared. And then limit x goes to infinity. So it's 1 plus 9 over x squared. If x goes to infinity, this is 0, this is 0, this is 0. So x goes to infinity is 1. X goes to a negative infinity, also 1. So the asymptote is, horizontal asymptote is y equals 1. Okay. Find the y-intercept, x equals 0. Y-intercept, x equals 0. Plug it in. X equals 0, plug it in. So find what is f0. And the x-intercept, which is y equals 0. You solve x minus 2, x minus 5 over x squared plus 9 equals 0. You solve that x equals 2, x equals 5. So x-intercept, plug 0 into it. This is going to be 0, f0. This is your x-intercept. You find f0 by yourself. Y-intercept. X-intercept y equals 0, so it's 2, 0. 5, 0 is your x-intercept. Okay, you can graph the function, okay, by using the x-intercept, y-intercept, oblique asymptote, and the horizontal asymptote, okay. You can use the graphing calculator to verify your answer, okay. That's what you can verify your answer by using the graphing calculator. But before you use the graphing calculator, you have to use the you have to find out that by yourself. How do you graph the function? There is another way to do it. You can use the online. There is a graphing graph functions. Okay. So there's an online graphing calculator you can use. You can check. I ask you to graph it first, then you check your answer. Okay. So basically, you just need to type in fx, you type in your function, okay? So you can type in y equals x minus 2 back times x minus 5 parentheses back divided by parentheses x squared basically we can do that, I think, and plus 9. Okay, so you graph it pretty much like this. You can see that you can make it bigger or make it smaller. You can see there's a horizontal asymptote is y equals 1, right? So that's, you can use that. You can use the graphing calculator to verify your answer. Once you graph it by yourself, you can see the x-intercept is 2 and 5. You see that? You can use several points to graph it. So number 6. Write the 7th term of m minus 3n to 14. So basically what you need to do, the first term is m to power 14. The second term is choose 1 from 14, and m to power 14 minus 1, negative 3n to first power. This is the second term. Third term is choose 2 from 14, m to 14 minus 2, and negative 3 to power square. This is the third term. Fourth term, choose 3 from 14, m to power 14 minus 3, negative 3n to power 3. And the continue is going to choose 4 from 14, m to power 14 minus 4, and the negative 3n to power 4. First, 1, 2, 3, 4, 5. You can do 6 is choose 5 from 14, m 14 minus 5, and negative 3n to power 5. You keep going by yourself. You know the 7th, I'm not going to write the 7th out. Okay, you write the 7th out, find it by yourself. So 1, 2, 3, 4, 5, 6. 7, you do it by yourself. Okay. So number 7, write the binomial expansion of this. So x power 4, 1 minus x power 4 raised to the power 4. So what do you do for this one? First, it's going to be 1 over x4 raised to the power 4 plus choose 4 from 1 and 1 over x power 4 to power 3 and raised to negative 4 raised to power 1 plus choose 2 from 4 and times 1 over x power 4 to square and negative x power 4 then square. Okay, then plus 4 to choose 3 from 4, 1 over x power 4 to power 1, negative x4 to power 3. You simplify that, okay, and plus choose 4 from 4 and 1 over x4 to power 0 and times negative x power 4 to power 4. You simplify this. This is just use a binomial formula. Find all rational zeros of fx equals 8x power 4 minus 14x power cube minus 29x squared minus 4x plus 3. Find all rational zeros. So all rational zeros, first one, what we can do is we have to test all the possible zeros. Possible zeros is positive negative 3 over positive negative 1, positive negative 2, positive negative 4, positive negative 8, which is, this is the factors of 3, okay? This is the positive of 8. So we test it. We try, say if x equals 1, does it work? Plug 1 into it. So f1 equals 8 minus 14 minus 29 plus minus 4 plus 3 doesn't work for sure. What about x equals negative 1? Okay. X equals negative 1, does it work? So f negative 1 equals 8 plus 14 minus 29 plus 4 plus 3. It seems like this one works. This is 22 plus 7 is 29 minus 29 is 0. So perfect. We have a root which is -1. So now we use the synthetic division. 8, -14, -29, -4, 3. And synthetic division, if x equals -1, so I put -1 here. And then bring it down, 8, multiply it, -8, add it, -22, multiply it, +22, add it, -7, multiply it, +7, add it, +3, multiply it, -3. So basically multiply it, multiply it, multiply it, add next one, 0. So now my function can be written as x plus 1. This is from here. X equals -1, which the fact is x plus 1. And 8x cubed minus 22x minus 7x plus 3. Okay, so I know I got one of them is x equals -1 is my 0. So I have to find the cube root. We don't know yet. We have to test it, try it again. So continue, try it. Try this one is also -1, positive -3, positive -1, positive -2, positive -4, positive -8. I would not try to use the fractions. I would like try 1 doesn't work, -1 doesn't work. So now how about 3? So I want to check if 3 works or not. So f3 equals 8 times 3 cubed minus 22 times 3 minus 7 times 3 plus 3. So if it works, 8 times 27 minus 66 minus 21. I don't think it works. It seems like f -3 doesn't work either. Okay, so need to test. Maybe now we have to test 1/2. So let's check 1/2. Although I don't know, I don't want to check 1/2, but now I think we need to check 1/2. 1 is 8 minus 22 minus 7 doesn't work. -1, so the 8 plus that doesn't work. So let's check 1/2. 1/2. Okay, plus 1/2 is 1/2. 8 times 1/8 minus 22 over times 1/2 minus 7/2 plus 3. It doesn't work. Okay, so let's check -1/2. f -1/2, which is 8 times -1/2, and power cube minus 22 times -1/2 minus 7 times -1/2 and plus 3. It seems like this is not working either. Okay, so f3 8 times 27 322 1/3 1/4 1/4 might working. Let's check. 1/4. Okay, so let's check 1/4, see if it works. So 8 times 1/64, which is plus minus 22/4 minus 7/4 plus 3. One-fourth. So if you do that, it cancels it out. So 1/4 is not working. And you have to check one by one, like 3/2, that's all of them, see which one works. Okay. So basically now I need to find out 8x cubed minus 22x minus 7x plus 3 equals 0. I need to find out the zeros of this one. So basically what you need to do, you check f1, f-1, f1/2, f-1/2, and f3, f-3, f1/4, 3/4, f-3/4. See which one give you zeros. Okay, so let me do a quick estimation. x minus 7x plus 3. So I think 3/8. X is minus 22x plus 7x. X cubed. Okay, seems like f, do a quick estimation. F-1 is one of the solution, and F3 is one of the solution as well. So let me check F3. What is F3? So let's plug F3 into the function. First x plus 1, bring down 8, negative 8, negative 22, and positive 22, negative 7, positive 7, positive 3, negative 3, 0. That's right. So let's check f positive 3 equals 8 times 3 times 3, 27, minus 22 times 3, minus 7 times 3 plus 3. Okay, so let me just check it, f3 on the original function. f3 equals 8 times 3 to the power 4 minus 14 times 3 cubed minus 29 times 3 squared minus 4 times 3 plus 3. So 8 times 8, negative 14, negative 29, negative 4, 0. Okay, 8 times 9 is 81 equals minus 14 times 27 equals minus 29 times 9 equals minus 12 equals, okay, plus 3. It works, equals 0. So I got two zeros. One of them is x equals negative 1, the other one is x equals positive 3. So you need to check this one. Let me see, 8, negative 22, negative 7, 3. If I do 3, plug it in, 8, 24, 2, positive 6, negative 1, plug in, negative 3, 0. Oh, it works. So now I have x minus 1, x plus 1, so x plus 1, x minus 3, and 8x squared plus 2x minus 1. So all of the rational zeros is x equals negative 1, x equals positive 3. So now you need to use the quadratic formula to find the, or you can factor, find the other two solutions. This is the quadratic formula. This is the quadratic equation. You should be able to find the two roots for this two, right? x3 equals what, x4 equals what, equals what, based on whatever this one gives you. Okay, so this is number 8. Group discussion. We just calculate a fractional factorial. A positive integer can be used that as example is 120. Stirling formula gives that. With the graphing calculus off by less 2, arrow of that. Use the calculator to find the exact value of 10 factorial. So basically, you can do 10 factorial. You can use a calculator equals 10 times 9 times 8 times 7 times 1. A lot of calculators can directly do 10 factorial. So what is 10 factorial? 10 factorial is, use a calculator 328800. Then you use 10 factorial, plug into the formula. 2 pi times 10 times 10 to the power 10 times e to negative 10. Okay, use the formula to find out 10 factorial, compare it. What is the percent error is subtracted, divided by the original, divided by the actual 10 factorial. So basically, you use this number minus this number, what you got, and divide by this number and multiply by 100 is percent error. So repeat question 1 and question 2 for n equals 12. That's not hard. So n equals 12. So you do 12 factorial. Use a calculator. Then use 12 times 11 times 10 times 1. Okay, you can do that. 12 factorial. And then you can do 2 pi times 12 times 12 to 12 power times e to negative 12 power. Okay, so you can also do 13 factorial equals 13 times 12 times 11 times continue times 1 equals what? Then you can use the formula 13 factorial equals 2 pi times 13 times 13 to the power 13 e to negative 13. Compare the actual value and the formula, and then Stirling formula. Compare these two values, compare these two values, compare the 10, see if there's any pattern when n gets larger. Okay, that's how you do this.